Okay, this is going to be the root test. Now, the root test is even easier. It's probably other than the limit test, it's probably the easiest one to apply. But it applies to very few things, unfortunately. They have to kind of look like this. They have to have some type of power to like it could be 2n, 3n, but it has to have an n in that power because if you look at what I did, I took the nth root. Now again, absolute value. See this? Absolute value bars. A lot of times within these questions, they like to do this. They like to do this. They like to do this. Right? They like to put these negatives in there. You can ignore them because you are taking the absolute value of these. These go away, right? The absolute value of a negative, right? So the point is they're always going to be positive. So, right, the nth root means 1 over n. So what I'm basically going to do is I'm going to divide all the powers by n, and I'll write that. Just like the ratio test. If this limit is smaller than 1, converge. If this limit is bigger than 1, diverge. If this limit is equal to 1, then you made a poor choice. You tried to use the root test when you can't use the root test. This is the only time that you get a 1, is right, and 1 is inconclusive. So look, I mean, I could show you how simple this is, right? Like if you had 1 infinity, and let's say you had 9 to the n over n to the n, right? Very simple. They both have an n. Now, the mistake I see students make is if I give you something like n to the third over 2 to the n. This is not a root test. This is a ratio test. You cannot divide this power by n. It's not going to do anything. All right. So you cannot apply this test. Important. Not apply this test unless you see these things here. Right. So you just divide all the powers by n. Divide all the powers by n. Powers by n. And then you take that limit as n goes to infinity. I mean, I really should have wrote that there, but it's here, so it's good enough. So watch how simple this is. I mean, you're going to take the limit as n goes to infinity. You're going to just divide, right? You're taking the nth root. What does that mean? It means that you divide everything by n, right? 1 over n. Look, 1 over n, right? If you do 9n to the 1 over n, right? Power to a power means you multiply them. If you times these together, the n's cross out. So on the top, you just get 9. On the bottom, you just get n, right? And n goes to infinity. That is supposed to be there. Being lazy because I'm just showing you. So that would be 0. So that one would mean converge, right? The limit is less than 1. So, sometimes they do something, looking for an example. Sometimes they do something like this. They give you like, I don't know, 3n minus 8 to the n over, I don't know, 2n plus 7 to the n. Right again, to the n, to the n. Just take that limit. I mean, it's ridiculously simple to see that this is going to diverge, but you're going to take those powers, you're going to divide them by n, right? Really easy. Divide them by n. Those cross out, get 1. Those cross out, you get 1. So the powers are gone. Look, woo, goodbye. Just divide them by n, they go away. So you're just doing this limit as n goes to infinity. This is L'Hopital. Highest power top, highest power bottom. This limit is 3 halves, which is more than 1. So then this one's going to diverge by the root test, right? Super easy to do. But like I said, very limited. It doesn't work on a lot of things. There's a lot of things that are not appropriate. Like I just said earlier, if you're trying to do that on this is a 3. If you're trying to do root test here, no. Ratio test, right? I mean, so the root test is very limited in where you can use it, but when it's perfect for stuff like this. I mean, because you can't really do this type of problem any other way. So that's what the root test is for. It kind of gets the last few that you wouldn't be able to determine by any of the other previous tests, right? There's a lot of tests at this point. So, like I said, root test, super simple. There's not going to be a whole lot of them, but they're very easy to do. They literally take like 2 seconds. You just divide the powers by n, figure out if it's bigger than 1, smaller than 1, and then it's over. Okay, so then that's the last of the tests I'm doing this semester. So at some point I'll teach Calc 2 again, and I have to do alternating series, I have to do power series, but we didn't reach it this semester. So if you're watching this way, way in the future, You'll see the other test videos there because I'll do them all. I just didn't do them this semester.